Hello, friends. This is a podcast to introduce section 5.6 in the Algebra 2 book. We are reaching the acme, the top of the Algebra 2 course. Recall that we have just finished working on problems like this, where you are given a polynomial like this, and they tell you a factor like this, and then they tell you to factor it completely. But what they've done is they've given you the first factor. So if we look at an example like this, you can see that once you divide out the factor they give you using the synthetic division, I can rewrite this whole polynomial as a product of this, the factor they gave me, and the answer to that synthetic division. And once it's down to a quadratic, which means just the highest exponent is 2, I now have the tools at my disposal, the experience, to factor this down. And once I get to 3 factors that cannot be made any simpler, I know I'm done. What we're going to be doing in this section is learning how to find that first factor on our own. In other words, instead of them having to give us x plus 2, we're going to find that x plus 2 factor ourselves. So to do that, we are going to use what's called the rational zero theorem. So we've got to recall a little vocabulary. Remember from earlier in the year that when we rewrote a polynomial, we put it in order from the highest exponent all the way down to the lowest. And once we did that, what was in the front was called the leading coefficient. So a to the n, which you see here as well, is the leading coefficient. It's the coefficient of the term that has the biggest exponent. We also talked about the constant, the number, the term that had no variable. So a sub o is the constant. And what this tells me is if I take all the factors of the constant divided by all of the factors of the leading coefficient, I'm going to get a list of numbers. And those are the only numbers that can be rational zeros. In other words, zeros that you could actually find on a number line that could be answers to this function. Or easily put, if I made a graph, the x-intercepts, the place where the graph crosses the x-axis, can only be one of those listed numbers. Going to be easier if we look at an example. All right, so here's example 1. Let's note the directions. Find zeros when the leading coefficient is 1. So this is going to be easier because the ones we're going to have to do are going to have a number here. But here, there's nothing written, so I assume that that is a 1. All right, that makes my life easier. So all I'm going to do now is find all the factors of 10. All right, so let me hit you with a quick review of factoring. So recall, when we talked about prime factorization, these were my prime numbers. And when we had to do prime factorization, I'm going to start with 10 because that's the one I need. I start with the smallest prime number. In this case, it's 2. And I say, does 2 go into 10? The answer is yes. So I write the result there. And once I have a prime number here, like the 5, I know I have all the prime factors. Okay. I also, though, have a 1 because 1 goes in, and I have 10. So I always have all the prime factors. I actually want all the numbers that go into 10. So this is what I'm going to do. I am going to list all those numbers that I just found, 1, 2, 5, and 10. And I'm going to put each one of those over all the factors of the 1, which of course is only 1. So you see the 1s right here. So what this means to me is that the only numbers that can be zeros or solutions to this function are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And that's 8 numbers, and I've got to test those till I find one that works. Now, how will I know if it works? I'll know if it works if there's a 0 at the end of synthetic division. So if you pause this, you can finish seeing what they did. Now, what they did is what we've worked on this week in class, which is they took that one factor they knew, okay, which was positive 1. They got a factor x minus 1, and they broke it down, and then they took what was left here and broke that down, and these were all the factors, and because those are the factors, these were the solutions or the zeros or the roots. All right, one more podcast.